they're talking about the various ways that habits form in the nervous system. And they mention with each repetition of a habit, small changes occur in the cognitive and neural mechanisms associated with procedural memory. So I just want to talk for a second about what procedural memory is. In the neuroscience of memory, we distinguish between what's called episodic memory and procedural memory. Episodic memory is a recall of a particular set of events that happened, whereas procedural memory is holding in mind the specific sequence of things that need to happen in order for a particular outcome to occur. So think of it like a recipe or a protocol, or if for sake of exercise, it's like sets and reps, or a particular course that you're going to run or cycle, or the number of laps you're going to swim and how you're going to perform it. It's very clear that for anyone trying to adopt new habits, getting into the mindset of procedural memory is very useful for overcoming that barrier that we call limbic friction. How do you do that? Well, a simple visualization exercise, or it doesn't even have to be done eyes closed. Oftentimes we hear visualization exercise. You think about sitting in the lotus position, eyes closed, and trying really hard to visualize something. It doesn't need to be anything like that. It can simply be, if you are deciding to adopt a new habit, to just think about the very specific sequence of steps that's required to execute that habit. And I'll use a trivial example, but this could be applied to anything. Let's say I want to get into the habit of making myself or someone else in my household a cup of espresso every morning. I would actually think through each of those steps. Walk into the kitchen, turn on the espresso machine, draw the espresso, walking through each of those steps from start to finish. And it turns out just that simple mental exercise done once can shift people toward a much higher likelihood of performing that habit regularly, not just the first time, but as they continue out into the days and weeks that follow. So that's remarkable to me. And the literature is really robust. Just one mental exercise of thinking through what are the sequence of steps required in order to perform this habit from start to finish can shift the likelihood of being able to perform that habit from unlikely or to moderately likely to very likely over time. And that's because it pulls from this process that involves our hippocampus and our neocortex and other areas of our brain and nervous system that engage in procedural memory. It shifts the brain towards a mindset, if you will. It's more of a neural circuit set, it would be more accurate, but a mindset / neural circuit set of doing things in a particular sequence, which allows that limbic friction to come down and increases the likelihood that we're going to perform that thing. Simple tool, but very powerful tool according to the psychology literature. And actually, the cellular and molecular mechanisms that underlie that sort of procedural memory stepping through phenomenon are known. In this article I mentioned, this beautiful review, they talk about so-called Hebbian learning. Donald Hebb was a psychologist in Canada and birthed this field that has now lasted, more than 50 years and is still very strong in neuroscience and psychology of Hebbian learning. Hebbian learning is when particular neurons are coactive, meaning when they fire together, they tend to strengthen their connections with one another. And it has a number of different underlying cellular and molecular features that we don't have to go into in detail. But for those of you that want to know, I know some of you are hungry for a little bit more neuroscience. This involves things like NMDA receptors, N-methyl D-aspartate receptors. NMDA receptors are really important, I think, for everyone to understand. So I'll just tell you a little bit about them. These are receptors that are on the neuron surface, and normally they don't contribute much to the activity of those neurons. Those neurons are perfectly capable of doing their thing without activation of this NMDA receptor. But when a neuron gets a very strong input, a strong stimulus, that NMDA receptor triggers a number of mechanisms that recruit to the surface of the neuron more other receptors. In other words, it makes that neuron more responsive to input in the future such that it doesn't require so much input. In other words, it takes a neuron that is very unlikely to fire and makes it more likely to fire. So this procedural stepping through of the steps of the recipe, or the series of action steps that are involved in sitting down to study and writing for an hour, or generating exercise, whatever it is the habit that you're trying to learn, when you're doing that exercise, it's not as if your nervous system thinks you're actually performing the behavior. Your nervous system isn't stupid. It's actually a lot smarter than that. It knows the difference between a thought and an action.